Hello, my name is Gregor von Laschewski. Swagger is a tool that allows you to specify and generate REST services in a relatively easy fashion. We will be going into this and start with the definition of what Swagger is. Swagger is a framework for API developers and provides tools for the development of a specification that is called OpenAPI. It enables you to develop the API as part of a development life cycle, leading from design to documentation to testing and deployment. Swagger is currently on a transition path from version 2 to version 3. Version 3 is the actual OpenAPI specification. However, at this time, not all tools are yet ported, including the Swagger CodeGen. We would like that you experiment with the version 3.0 and give us feedback if this works, and then we can naturally switch to 3.0. Advantages of Swagger include that it provides a standardized API design and also a design process. You can collaborate during the API design process with your colleagues, and you can interact through an API design editor with each other. It's really important to understand that the standardized API design process can be extremely helpful, because if you're working with a large group of people in defining, for example, a standards API, they can all collaborate with each other. The nice thing about Swagger is that it provides a browser-based editor that supports this particular design process. In addition, when we are looking at the APIs themselves, we may be developing multiple APIs, and we have really between these similar designed APIs a very similar design process, thus at one point speeding up the design and also solidifying the design. We start using this API design process by interacting through an editor and providing an initial specification. And this allows us to focus on the actual API rather than focus on the design of the back-end system first. Thus, we can test the API design before we actually build the back-end services, while just using client-server invocations and interact with our design processes. Additionally, an important feature of Swagger CodeGen, which is a tool to generate the code, is that it supports 30 different languages, and that's naturally an important feature for us, because this way we design an API that's language independent. The collaboration during the design process, we already pointed out, we can work with teams that work together on the API design process. Thus, we are solidifying the design, and we verify with many people that the design actually does work. In addition, we have a versioned API design process in which we can associate a version with each API, thus making it clear that we can improve things, but at the same time stay very focused on already existing API designs that we have done in the past. We can integrate this particular activity in our software engineering process of design, review, and refinement. The editor allows us to visually render the API, and it also allows us to use existing Swagger APIs that have been defined by other people and add to them documentation in the continuous design process. We expose the API through the web in a visually appealing document that can be integrated in many different REST services, such as Django or Flask or many Java-related REST frameworks. We built incrementally on top of existing API documentation that allows us to leverage other people's efforts and integrate this in a very large API document that we can share in our activities. Let's revisit which open source Swagger tools are existing. We have the editor, which we already pointed out. We have a tool that can generate client and server tools, server code. We have a user interface to visualize and interact the API's resources as part of the editor as well as web interfaces. We have an inspector that we can call and validate the API. We will focus mostly here on the editor and have provided here a snapshot of the pet store example that is being typically provided with Swagger and showcases you how this editor looks like. And we see that's a YAML document, and the specification itself is provided on the Swagger website. And some information is also provided in our handbook that we provided in a separate chapter. What we would like you to do is to revisit these two documents and understand how to design Swagger APIs. We will not go into this presentation in detail about this. It is much better to look at the documents, and also because in future we will be switching from version 2 to version 3, and so we want to make sure that you are taking the version that is most appropriate for you. Once you have designed the specification in the editor, which you can install locally or which you can use online as the browser, you can generate the code. The program to generate the code is Swagger CodeGen, and you can create client as well as server code. The client code is relatively easy to create because there's not much that we need to be changing. It just gives you functions and routines to interact with the server. However, on the server side, we have a lot of code changes to do at the intersection where the API actually invokes real functionality. And this is being showcased in the code itself with the line return do some magic. And you have to probably locate all of them in the Swagger server code generated code and replace this with real code. Let's walk through the step that we have. We assume that you have Swagger CodeGen installed. This can be done easily because it's a Java tool, and you can make sure that you have the right version of Java and you install it. On OS X, we recommend that you use brew install Swagger CodeGen as documented in the Swagger documentation. So first we have to certainly start up with defining your REST service through the specification. As mentioned, we are using the 2.0 specification at this time, and you define a valid Swagger document. You can verify this online if this document is valid, and once it's valid, we can create the server-side code. Let's do this in step 2. So naturally, as I pointed out, you need to have not Swagger CodeGen installed. That's really easy, as I pointed out, as either Java or brew. And once you have installed it, you can invoke this through, for example, the following command line that's also posted in the handbook to make it really easy for you to identify what needs to be done. You can have a choice to support Python 2 or Python 3. Please look it up in the manual page to Swagger CodeGen so that you can identify what are the appropriate options that you need. The -O flag specifies where you are storing your code at, and make sure that you define the right directory where you would like to have your code exposed to. And the -I flag is specifying where the input file for the Swagger specification is located, here in this case cpu.yaml. In step 2, which is now the continuation, we find under Flask connection directory, which we have specified as the output, a Swagger server directory under which you will find all directories with the models defined and controller stubs that have been generated by the code. The models called are generated from the definition provided in step 1, where we gave you the YAML file. And on the controller code, though, we will need to fill in the actual implementation as previously indicated, which we showcase to you in the next slide. Here's then the example of the server-side code. You will find a function, for example, such as this: define CPU get, and CPU get returns an info as specified in the Swagger code specification. However, you find here the red highlighted line, return to do some magic, and that is the line that we need to be replacing. Let's do this with some real content. So, as you know, Python provides the platform interface and a module, and with this we can query the system and some information in the system itself. On Windows, it's different than on Linux or Darwin, but in order for us to create a code that runs on all of the machines, we just simply query on which system we are executing the code and invoke the appropriate platform-related command. And in this particular case, we just would like to identify the processor name. And for each one of these platforms, we have provided one way of how to identify the processor name. There could be different ones. So we have just given you here a variety of methods just to showcase that there's something to be done differently on each one of the machines. If I can't find the processor name or the system name, I simply return cannot find CPU information. Now, as you see, we have here a get processor name as a function, and we also have a type associated with our CPU get function that we specify through the Swagger specification, such as CPU. In here, we are now returning the CPU as defined by the information through the get processor name function. As you can see, we are not modifying the CPU get function in here, and we are not even providing the previous code into that method. We should not do that. However, we should be putting it in its own module that we hopefully install with the setup.py command, and simply invoke as a library call into this particular piece of code. This has the advantage that if we were to change our mind about how the API should be defined, we still are reusing or can reuse the previously defined backend service process or function that we have identified will provide us with the information. After we have done all of this, we need to be running the REST service. We have to say that we either recommend using PyEnv or virtualenv. I prefer to use PyEnv, but PyEnv also supports virtualenv. So set up a virtual environment with all the activities that with all the libraries that you need, and you can activate that particular virtualenv. You can go to the directory where you have actually your server code installed, and you can simply say in that pip install. But before you do this, you need to be making sure that you have the newest version of pip installed, otherwise it may not run. So update your pip, then you go to the directory where you have your code generated. You call pip install -r requirements for the requirements. Then in the next step, you need to be doing Python setup py install, and now you can run the server with simply Python -m swagger server. This happens in one terminal. Please don't Control-C this, but just keep it running. Open up a new terminal and issue in the new terminal, or open up a web browser and issue in the web browser the HTTP call to this particular location, because we have defined a route to API CPU. This will then return you the information as you will expect. That's really good because we have now defined how we interact with this through a web browser. Naturally, you can use a curl command to do the same thing. Now it's time to look into how do we define clients that are interacting with this particular service. The good news is that Swagger also provides client-side code that verifies essentially our REST API, and you can generate this also with Swagger CodeGen. It will be up to you to identify how to invoke these client-side codes from your local Python installation so that you can verify the code. Next, we would like to introduce you to a different client. This client creates the code without invoking Swagger CodeGen, and it's called Bravado, which is a fork of Swagger by Yelp. Bravado's features include the following. It is a Python client library, so it's limited to Python, and it uses Swagger 2.0 code specification. It uses the Swagger models as Python types. That means you don't need to deal with JSON or other types from the specification. You get automatically designed types, so you don't need to do that. You also don't need to create any code, so no code is being generated. It's automatically generated once you invoke the client-side specification. So let's try Bravado. Naturally, you need to be installing it. Again, make sure that you have PyEnv or virtualenv where you're using it. And the code on the bottom showcases how simple it is to invoke the Swagger client. So here we actually import from Bravado the Swagger client. We instantiate the Swagger client and read from the URL the appropriate specification. Here we are using the pet store from Swagger, and invoking or getting a pet is as easy as querying it, for example, by ID, and we get a result and should be printing it, for example. Naturally, it requires that that pet with the ID 42 actually exists, so we need to be making sure that we upload some information. And let's do this here in the second call. Here we create a pet. We create a client and obtain it from the model that we have. This is our type. We also need to be looking at the category that we want to have. In our case, we want to have an ID of 24 or maybe some other things, and we put it into the ID 42 that we want to actually read out, and we can invoke the pet on an add call into the next line, where we query also the result. So it's as easy as this. As Swagger CodeGen and also Swagger can support different authentication modules, which we haven't really showcased you in much detail, we can naturally also add a basic authentication and other form of authentication to Bravado. Here's an example, and we leave it up as exercise for you to augment your service that you have created with Swagger CodeGen with basic authentication. More importantly is when we have many different calls to make, sometimes it will take time to execute them. We may want to do asynchronous client calls. In order to enable them, you not only need to install Bravado, but Bravado of Fido, and you need to be doing this particular pip install to enable this. Then, when we create the client, we have to add the Fido client as a parameter. This allows us to get asynchronous client calls and can even specify a timeout as part of the result return function. If you want to run Swagger without any models, we can even do this by specifying the config and use the models false. This way, there will be no verification being done when we are interacting between the client and the server. When we compare Swagger client versus Bravado client, we find the following. Swagger is provided by the developers of Swagger, so we are somewhat in a good state because they are trying to update these APIs and the code gen so that we can reuse them. At this time, 30 languages are supported. However, the code has to be generated. This has to be done on the server side as well as on the client side. So if the API changes, I do have to do some modifications to my code. Bravado, however, the code is auto-generated, so I don't have to modify the code. However, when I use Bravado, there could be naturally different uses occurring depending on what I've actually changed in my API. Another disadvantage actually is that it's only available in Python. So as conclusion for our work, this is because we are trying to establish a more standardized process and standardized objects that are independent from languages. It seems to be better to look into Swagger client instead of using Bravado as the client. Thus, I would like to encourage you to focus on Swagger client and not use Bravado client. As references, we have here the following references, Swagger and Bravado. And in order for you to fully understand the schema and the specification of Swagger, you have to read our handbook chapter on this, as well as going to the Swagger website and reading up on the documentation how to specify such a schema. This is beyond the scope of this talk, as it's much easier to read it up in a manual than to describe in words. Thank you so much.